Evening.
Sir, my brother, he went to play. He will come soon.
Okay, okay. So meanwhile, if you have any doubt, so you can ask.
Yes, sir, I will.
Okay, tell me.
Just a second.
Mm-hmm.
No, sir, I don't have any doubts.
Okay. So let me draw the two diagrams which we were doing yesterday.
Okay, sir.
So these were two theorems. Theorem 10.6. Okay, so in that there is a circle, and in this circle there are two equal chords. One is this, another is this. A, B, C, D. So here we are given that AB is equal to CD, and here to prove that distance of AB from center is equal to distance of CD from center. So we drop a perpendicular here and one perpendicular here. So what we are doing that we have already done yesterday. Okay,
Yes, sir, yes, sir.
so let's suppose this is point M, this is point N. So to prove is OM is equal to ON. This is one theorem, and another one which is very much similar to this is 10.7. Okay, so here again we are having a circle, and this is the center. So we are having two chords. Okay, let's draw another one also equal to this.
Sir, this is the second one, right? Of theorem 10.7.
Yes,
Oh, yes.
this is point O. So in this theorem, it is given that distance of both the chords from the center is equal. So if it is M and this is N, so now here we are given that OM is equal to ON,
Yes, sir.
AB, CD. And here to prove is
Oh,
AB is equal to CD.
BC.
Okay,
Oh, C.
so this is the only difference here we are having.
Oh, okay, sir.
Okay, so we have to wait for Ali, then only.
Yes, sir. He's going to the room, study room.
Okay, okay. Okay, Ali, you came.
Good evening, sir.
Good evening, Ali.
Evening. Sir, today there was a test in my class, okay, sir, about the
Okay.
circles only. So,
About?
our class teacher, a circle, sir, he was normally taking tests, sir, to check whether
Okay, okay.
students were prepared or not.
Okay.
So, after the test was over, sir, he said that this exact questions will be there, but in different, this will be exact format, sir. The format, it will be the same, but the question will
Mm-hmm.
be something different, sir. 80% of
Okay.
the question, 80% of the marks will come from these types of question only, sir. So he
Okay, okay.
sent me the paper, sir. I'm going to send you right now, okay?
Yeah, yeah, send it to me.
Sir, my teacher said that the questions are going to be the same but different kind of questions. Like it's going to be
Hmm.
same but the numbers and everything is going to be different.
Okay, so there was a test in your class also
Yes, sir, revision tests are going on.
for this chapter, circles.
Yes, sir, but she gave
Hmm.
polynomials ka chapter.
Okay, circles and polynomials both.
Yes, sir.
Okay, so means you should also send me the paper so that
Yes, sir, I will send.
yeah.
I will rewrite it and send because I wrote
Hmm.
it really fast.
Okay, no problem.
Okay.
Actually, let us proceed with the means questions and theorem we are doing, and actually we cannot include the questions right now. Ali,
Yes, sir. Yes.
you just send me. I will observe the questions and we will means try to do only those. Okay,
Yes.
but let's proceed for this lecture in this with these questions, theorem and exercise 10.4. Okay, so these were the two theorems and we should do these simultaneously. Okay, why? Because then only you will see what is the difference. Okay, so in 10.6 the given data is that two chords are given to be equal. Okay, Lee?
Yes, sir.
So he is asking to prove that if two chords are equal, so their distance from the center will be equal, right? So for the distance of a line from a point, we need to drop a perpendicular, right? So we drop a perpendicular at AB and a perpendicular at CD from point O. And the point we got here is M and the point we got here is N. So the distance will become OM. Distance of AV from center will become OM and distance of CD from point O will become ON. Right? So we require to prove that OM is equal to ON. Right? And what is in 10.7? The only
Sir, can you
difference.
please repeat?
Sorry,
I didn't understand. Can you please repeat, sir?
I should repeat.
Yes, sir.
Yes, sir, that's what it is.
The whole statement from starting. Okay, so here we are given two chords AB and CD are two chords. Okay, two chords of a circle, right? And they are given that both the chords are equal in
Yes, sir.
length, right? So the length of AB is equal to length of CD, right? So now we are required to prove that their distance from the center will also be equal. Okay, if you read the statement, it is that 10.6 equal chords of a circle are equidistant from the center. Equidistant means the distance is same. Okay, so if you take the
Oh,
distance of this chord from the center, it will be OM. Okay, because for the distance of a line from a point, we need to drop a perpendicular. Okay, so this will be the distance of any line from a point. So for this we drop a perpendicular on AB and we drop a perpendicular on CD. Okay, now these are the distance from the center of the chord. AB and CD. So we require to prove that OM is equal to ON. Now you got it?
Yes, sir.
Yes, sir.
Okay. So let us proceed with 10.6 first, then we will go to 10.7. Okay. So for this, let's join this O to B, okay, and O to C. Okay. But what you do in the exam, you also write this statement that let's join O to B and O to C. Okay.
Sir, but how are we supposed to draw this? Like, are we
Sorry,
supposed to keep? How are we supposed to draw this?
means how to construct this.
Yes, sir. Yes.
Okay, you draw a circle. If it is not possible to draw it freehand, you can use the compass. Okay,
Yes, sir.
and for drawing the line, use the scale. No problem.
Okay, sir.
Use a scale to draw the line and use a compass to draw the circle and take the center. Okay, you can take approximate distance. It is not necessary if the chord are given equal, so we should draw equal exactly, but approximately it should look equal. Okay,
Oh, okay.
because construction is different. Okay, and theorem part is different. In
Yes.
theorem part, we are not supposed to draw it in exact manner. We just supposed to prove it logically.
Okay, sir.
Okay, so now we can proceed from here. We have two triangle. One is OMB and another is ONC. Okay, so in triangle OMB and ONC, triangle ONC. So what is the thing you can say that these are equal in these two triangles? Huh?
So, sir, 90 degree
Which angle is 90 degree?
in the triangle
So both
Yeah.
are 90 degrees.
is 90 degrees.
Yeah, these two angles, na? These two angles. Okay, so we can say that angle OMB is equal to angle
OM
ONC. Okay, you know na how to write angle.
and ONC.
बेटा एक सेकंड जरा होल्ड रख.
Yes, sir. OMB is equal to ONC.
क्या हुआ? हाँ?
Yes, sir.
बाहर. Okay, beta. So you are clear na how to write an angle?
Yes, sir.
Okay.
Yes,
So
sir.
OMB is equal to ONC. By equal, you can write both are 90 degree. Okay. Any other thing?
Sir, I've sent the questions on the group.
Sorry.
The
Okay,
questions
okay.
I've sent in the group.
Okay, okay. I will see it after the class.
Okay, sir.
Okay. So what is the other thing you can say it is equal? It is OB is equal to OC. And why? Ali.
Sir, OB is equals to OC because, sir, they both are right angle triangles, right? First,
No, no, no. Right angle triangle means they
90 degrees.
no 90 degrees. Okay, but this length O to B and O to C, this length will be equal. Okay, but what is the reason?
Sir, because they both are connected to the radius.
Yeah. This is the reason. You can say both are radius.
Yes, sir.
Oh,
Both are radius. Radius of the circle. Okay. So in a circle you can draw any radius in any direction, that will be equal to exactly to the radius. Okay, so OB is equal to OC. And what is the last thing we can find to be equal? Okay, so let me write this. It is MB is equal to NC. Okay, means this length M to B will be equal to N to C. Okay, so why it will be equal? It will be equal because means previously we have done this theorem, I think 10 point, which one? Bisect the chord, yeah, 10.4. Theorem 10.4, you remember?
Yes, sir.
What is it?
Sir, congruent, right? Sir, something.
No. 10.4 is not 10.4, actually 10.3. Okay, so 10.3 is the perpendicular from the center of a circle to a chord bisect the chord. If you recall the theorem 10.3, it is perpendicular from the center to a chord. Means if it is a center, if it is a chord, if you drop a perpendicular, so it will bisect. Bisect means it will divide the chord into two equal parts. Okay, so like here we have taken that this angle is 90 degree in both the chord. Okay, so it is clear that it will bisect the chord, means AM will be equal to MB here. Okay, and in this chord CD, this distance NC will be equal to ND. Is it clear?
Yes,
Okay,
sir.
so if these two are equal, we are not saying that this is equal to this one. Okay, but it is given that AB is equal to CD. Okay,
Okay, sir.
means the total length of these two chords are equal, so the half length will also be equal. Ali and Zainab,
Oh, yes,
means
sir. Yes, sir.
if there are two lines, okay, this is one line, this is two line. Okay, so we are saying that these two lines, the length is equal. So if I take the half distance of these two lines, that will also be equal. Okay,
Yes, sir.
so in this data we can simply write that it is given, but given, I think writing given is not enough. We can quote the statement of 10.3. Okay,
Yes, sir.
here we should quote the statement of 10.3. It is that perpendicular from center bisect the chord, and as AB is equal to CD. Okay,
So we can write theorem 10.3 instead, right? Because
but
we are doing that.
but anyone can question that if it is not in any book, if it is not given 10.3, then how can you write 10.3 only? Actually we should write the statement. Writing the theorem number is not enough.
Oh, okay, sir.
Okay, in a very short way you can just write that it is perpendicular bisecting the chord. Okay, and it is given that AB is equal to CD. Okay,
Okay, sir.
so from here, as three of the parameter of two triangles are equal, so we can say that both the triangles are what? Congruent. It means triangle OMB is congruent to triangle ONC, right? So if these two triangles are congruent, then we can write that OM is equal to ON, because these are the corresponding part of congruent triangle.
Yes, sir.
This OM and this ON, clearly these are the corresponding part of the congruent triangles. Okay, so this we require to prove. Okay, so here we can write hence proved.
Sir, give me 1 minute. I'll copy, sir.
Oh yeah. Do it first.
So, see. Okay. Equals to angle
Sir, in the theorem 10.7,
Hmm.
if
Yes,
ma'am
10.7.
says that how, like, if ma'am says that prove AB is equal to CD,
Yeah.
so like I have to, I think there are steps for that.
Sorry.
Are there like steps to prove AB is equal to CD? Like,
Hmm. Means we can do it in a similar way, like we do 10.6. Okay. So the only difference will be, means let you note down first. Have you noted down this one?
No,
yes,
sir.
sir, I did it.
Okay.
Uh,
So first note down, then I will tell you what to do in 10.7. Okay.
yes, sir.
Because only one change is required, but everything will be same.
So what are the is and M P equals to N. Sir,
Hmm.
MB is equals to NC.
Hmm.
Perpendicular from center.
Bisect.
Okay.
Bisect the chord.
Sir, perpendicular is exactly 90 degrees, right, sir?
Yes, yes,
So, sir, perpendicular from the center bisects the chord, sir. So, sir,
yes.
where is perpendicular line over here, sir? Like it should
Thi-
be. Is that A and B? It is no, sir. The M is it perpendicular?
Yes, yes, yes. Means on this line AB. Okay.
Sir, and one more thing, sir. What is an hypotenuse angle, sir? I don't know.
Hypotenuse angle.
Yes, a hypotenuse. It's something like that. So the question.
Okay. Hypotenuse is in a right angle triangle. The longest side is known as hypotenuse.
Okay.
Okay. Means
Yes,
if
sir.
it is a right angle triangle, this angle is 90 degree. So the side which is in front of this angle, that is the longest side. Okay.
Yes.
So that is known as hypotenuse. This is known as base, and this is known as height. Okay. So as you see here also, this angle is 90 degree. So this OB is the hypotenuse for this triangle. OB.
Okay.
Okay. And here OC is a hypotenuse.
I see. What's the chord?
Okay.
This is the bisect. So can it be possible, sir? All angles in a triangle are equal, sir, and there is no hypotenuse in that.
No, then yeah, it is possible that all angles are equal, na?
Yes, sir.
Yeah, it is possible. Then it will not be a right angle triangle. If all the angles are equal, so each angle will be 60 degree. Okay.
Yes.
Means a triangle have only three angles, and the total of these three angles is 180. So each is going to be 60. Okay.
Yes, sir. Triangle OMB is congruent. Triangle OMC. OM equals to ON SCP CT. Finish, sir. Sir, finished.
Finished. Okay. Okay, so for 10.7, the only thing is what was given in 10.6. Okay, here we require to prove it, and what was to prove here? Here it is given. Can you see this?
No, sir.
Yes, sir. But like in theorem 10.7, I have to do all those steps, right?
Yeah.
The same steps we did in 10.6.
Yes. Means there will be one difference only. Okay, because if you see that this data was given, AB is equal to CD, right? And here it is to prove that he is asking to prove that AB is equal to CD. Okay,
Yes, sir.
and what is here given, if OM is equal to ON, we are required to prove that OM is equal to ON. Okay, can you see this difference? Right, so the only change is going to be with this thing.
Oh, okay,
Okay,
sir. Okay.
okay, means we will join this O to B and O to C again. Okay, and then we will consider these two triangles, right? OMB and ONC. Okay, so this 1 and 2 means this angle, and this OB is equal to OC. So we will take same in this theorem also. But the third one, for this we will take that OM is equal to ON, right? Because it is given. Okay, and
Okay,
before
sir.
it, angle OMB is equal to angle ONC, and next
Yes.
is OB is equal to OC. So you got three things in these two
Yes,
triangles,
sir.
OMB and
Yes.
ONC, right? So now we can say that triangle OMB is congruent to triangle ONC, right? And if the triangles
Yes.
are congruent, okay, so we can say that MB is equal to NC. Okay,
Yes, sir.
so we have not got this AB equal to CD, but we have got MB is equal to NC.
Maybe.
Means this MB is equal to this NC, right?
Yes,
So
sir.
again we will quote this statement. What is that? That perpendicular bisect the chord. Okay,
Yes, sir.
so here we are bisecting this chord, and here also we are bisecting this chord. So if the half distance means, consider that there are two lines, okay, and we are bisecting these two lines. So if the half distance is equal, so the full distance will also be equal.
Yes, sir.
Ali,
Yes, sir. Yes, sir.
you got it?
Yes, sir. I got it.
If the half distance is equal, so the full distance will also be equal, because we are bisecting it, means two equal parts. Okay.
Yes.
1 minute, sir. 1 minute, sir.
Mm-hmm.
How, sir? Can you please repeat that part, sir? The equal parts, sir.
Okay, means we got from here that MB is equal to NC.
Okay.
Up to here it is okay. Okay, and we want to say that AB is equal to CD. Okay, so what logic we can give, because this perpendicular is bisecting the chords, means OM is bisecting AB and ON is bisecting CD. Okay, bisecting means dividing in two equal parts.
Yes, sir.
Okay, so if means we have two lines, right, and we are bisecting them, and we are saying that this part, half part is equal to this part. Okay, so if
Yeah.
half distance is equal, the full distance will also be equal.
Yes. No, no, sir. How?
Okay, so just a minute. Means I can do the only the last thing. Okay.
Okay.
Okay. What happened? I think my charger is not working. Just a minute.
Yes, ma'am.
Yes. Okay, so up to here it is okay. OM is equal to OM. Sorry, MB is equal to NC. Ali.
Yes,
Yes,
sir.
sir. It is.
Okay, so let me draw it here again. So in this circle, means the circle here, we have two chords, right? One is here and another is here. Okay, AB and CD, right? And we drop two perpendiculars, one on this chord, another on this chord. So this is point M and this is point N and this is the center, right? So according to theorem 10.3, it is clear that any perpendicular to a chord bisect the chord, right? Means we know that AM is equal to BM
Yes,
for
sir.
this chord, है ना? And similarly, NC is equal to ND.
CD.
This for this one means this half distance is equal to this one. Okay.
Okay.
So
Yes.
now in these two triangles, by proving that they are congruent, we got that MB is equal to NC.
MC.
You got it?
Yes, sir.
Right. So if we got that these two parts are equal, okay, and these are the half of this full AB, okay, means this we can say if these two are equal, so AM or 2AM is equal to AB. Ali,
2 a.m., sir.
Sir, I didn't get it, sir. 1 minute.
I didn't get
Means-
it from 2 a.m., sir.
no, if you
Why?
double the distance, this AM, if you double this
Oh.
distance, you will get
Okay.
AB, na?
Yes, sir.
Oh, yes, sir. Yes, sir.
Yes, sir. If you double this distance, you will get AB. Okay.
Okay.
So just suppose you got this, right? So you multiply it by 2. So it will become 2MB is equal to 2NC. Okay. Because it is no harm if you
Yes, sir.
multiply by any number in both the sides,
Yes, sir.
right? You can do it. So 2MB means 2MB means this is MB. Okay. So if we double this distance, then we will get AB.
Yes, sir.
Means this is MB, this distance is MB. If we double this, if we multiply it by 2 times, then we will get AB.
Yes, sir.
Okay, and similarly here, this is NC, this distance is NC, and if we double this distance, okay, so we will get what? CD. Okay, so you can also do it like this, just you take this and multiply it by 2.
Okay, sir.
Okay, and in the next step you can write that AB is equal to CD.
Yes, sir.
Okay.
AM. AM is equals to BM. NC is equals to ND. Where MB. So NC. So is it MB is equals to MC or NC?
NC. N.
Okay.
NC.
Equals to NC. 2 C. Sir, you did ND, right? So if you multiply two, if you multiply two, okay, sir, how will we get CD, sir? We should get DC, right? Oh, okay. Stuff. Yes, sir. Correct.
CD, DC, no
Same,
problem. Same.
Okay, sir. Finished.
Okay, so now we are moving to exercise 10.4.
Okay, sir.
Okay, so first question, can you read the first question?
Yes, sir. 1 minute. Exercise 10.4, right? 1.
In my book it is page number 179.
179. Yes, sir. Two circles of radii 5 centimeter and 3 centimeter intersect at 2 points, and the distance between their centers is 4 centimeter. Find the length of the common chord.
Okay, so the construction is like this. We have two circles. One of radius 5 centimeter and another of radius 3 centimeter.
Yes,
okay,
sir.
so let's suppose these are two circles, and let's say this is the center of this circle and this is the center of this circle. Okay,
Yes, sir.
so just mark here that this is radius r1, and anywhere mark here this is radius r2. Okay, and write r1 is equal to 5 centimeter, r2 is equal to 3 centimeter. Okay, now suppose this is the center of this circle O, and this is the center of this circle Q. Okay, now if you join this line, center to center line, okay, so the distance between the center is given as how much? 4 centimeter.
Yes, sir.
Okay, and we need to find the value of this common chord. Sorry. So where will be the common chord? Means
So in the
means there are two common points here. Let's say this is A and this is B. So just join A to B. Okay, just join A to B. So this is your common chord AB, and we need to find AB.
yes, sir.
Diagram is clear?
Yes, sir.
So here we will means you can say apply the theorems, right? Theorems means, let's suppose this point of intersection between the chord and the line joining the center is M. Okay.
Yes, sir.
Sir, we have to draw this diagram roughly in the exam, like rough draw. we have to draw this roughly.
Yes, yes. Actually, without diagram, I don't think that
No,
we will
like
be.
with the compass and stuff. No, right?
No, 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 no need to use compass and everything. Okay, if it is means you are not you are not means getting to draw a circle with free hand like this. Okay,
Okay.
otherwise draw only free hand. No, you need to use
Okay, sir.
compass.
Okay, sir.
Hmm. Because these diagrams are only representation. Okay, these
Yes,
are
sir.
not exact diagrams. This is only the representation.
Okay, sir.
Right. So how to proceed for this? We need to find the magnitude of AB, means the length of AB. Okay, so here if we join this O to B, okay, and Q to B, just join with a dotted line, right? So O to B and Q to B. Okay, so now what we got? We got two right angle triangle. Okay, so one is here, one is here. Can you see the red line?
Yes, sir.
Okay, so one right angle triangle is here and another right angle triangle is just in the other circle. So which color? Mhm. And another is here with the blue one. Okay, and this line MB, M to B is common for both the triangle.
Sorry,
Ali,
sir.
means this MB, M to B,
Sir, I
this
can't
line
hear
is
properly, sir.
common.
What is it?
This line is common for both the triangle.
Yes, sir. Yes, sir.
Means you can see that there are two triangle, two
Yes,
right
sir.
angle
Yes.
triangle, because this
Sir, your
angle is
voice is
90
breaking,
degree
sir.
here, this angle is 90 degree. Ali, are you saying anything?
MB is the common chord, right, sir?
Yeah, MB is a means AB is a common chord, not MB. This A to B is a common chord. MB is half
Yes,
of
yes.
AB.
Like
Yeah.
yes, sir. But in the triangle,
Okay.
Mhm.
that it's
Yeah,
the
in the
common.
triangles, MB is common. MB
Yes,
is common. Okay, so what we can say, MB is half of AB. How can we say this? Ali, Janab.
Sir,
yes, sir. Yes, sir. MB is half of AB.
How can we say?
Uh,
Because means if we take a common chord and if we bisect, so the line bisecting will pass through the center. We did this
yes,
question,
sir.
question number 3 from exercise 10.3. Okay, so means
Yes,
if
sir.
this line is passing through the center, so it is bisecting the chord, the common chord.
sir, I didn't
Yes,
hear
sir.
anything, sir. You just said, sir, because your voice was breaking.
Okay, so means, but Zainab, my voice is clear, no?
Yes, sir. It is clear for me.
Okay, okay. So I can repeat Ali, where from where you are not means getting my voice from the starting or where?
From the
Where it
starting, sir,
break?
like I understood till when you said that the red line. After I started breaking, sir, I
Okay,
tried
okay,
calling
okay,
sir
okay.
Ankita ma'am. No one answered.
Okay, okay. So I was saying that there are two triangle. One is here with the red boundary and another is here with the blue boundary.
Yes, sir.
Okay. So this M to B distance is common in both the triangle,
Yes, sir.
right? And we are saying that MB is half of AB.
MB. Okay, sir.
Okay. How we are saying? Because we prove it that line bisecting the common chord passes through the center,
Yes, sir.
right? And these are the center point O and Q. Okay. So what we can do? We need to find AB. Okay. This is the finally value we need to find, right? And we are given with this distance between the center and the radius of both the circles. Okay, so in this triangle, in triangle OMB. Okay, so OMB is a right angle triangle. Means if I draw the triangle here, it is like this.
Yes, sir. Yes.
It is O, it is M,
MB.
and it is B.
Yes,
Okay,
sir.
so this angle is 90 degree,
Yes.
right? So it is a right angle triangle, right? And in this triangle, this side is hypotenuse.
Yes, sir.
Okay, hypotenuse, and you can take it as a base and it a height. Okay, and it a right angle triangle, we can apply Pythagoras theorem by Pythagoras theorem. You know Pythagoras theorem?
Oh, no, sir.
Ali?
Yes, yes, sir. I know, sir. You told me right last time.
What is Pythagoras theorem?
Mm.
So if we apply Pythagoras theorem in this triangle, so what we can write?
Sir, 1 minute, sir. Pythagoras. Sir, we can write, sir, A into B.
Not A into B.
Sir, sir, A square plus B
Yeah.
square underscore root, right, sir?
Yeah. A square plus B square in under root is equal to?
I don't know, sir.
Okay. Actually, A square B square, it will not be possible to where is A, where is B. So if you want to remember, just remember it like this, that hypotenuse का square is equal to base square plus height square. Okay, hypotenuse square is equal to base square plus height square, and it is apply only in a right triangle. Okay, so we can also write that in triangle OMB, which is a right triangle.
Okay, sir.
Right triangle means one of the angle is 90 degree. Okay, so in any triangle, if one of the angle is 90 degree, then only we can apply this theorem, otherwise we can't apply.
Yes, sir.
Okay, because there will be hypotenuse. Hypotenuse means the longest side or the side in front of the 90 degree angle, that is known as hypotenuse. So hypotenuse square is equal to base. So in out of these two, anyone you can take as a base. So one will be base and another will be height. Okay, so the line vertical we consider as height and the line horizontal we consider as a base. That is a common rule. Okay, so here hypotenuse square is equal to base square plus height square. So if we apply here this, so we can write that OB square is equal to OM square plus MB square. Is it okay?
Yes, sir.
Yes, sir.
Okay, just remember this, and from next time we will directly write in this form. Okay,
Okay, sir.
right. So this OB means in this circle, what is OB?
Sir, OB is
Radius.
the hypotenuse.
No.
Radius.
OB is also radius, no? It is hypotenuse, but it is also equal to, the length is also equal to the radius.
Yes.
Okay, so in place of this OB, we can write 5. So 5 square, okay, is equal.
Sir, I have one question, sir.
Hmm.
Sir, in here, sir, in OB, sir, you wrote R1, sir, at the ending, sir, of that line, sir, of the chord, sir. What is that R1? Radius. one.
Yeah, radius. R1 means radius of this circle.
Okay, sir.
Actually, if there is only one circle, okay, so we can take R. But as here we have two circles, so just for the symbol we take R1 and R2.
Okay, sir.
Okay, this is just the symbols. Because there are two circles, so we have to take R1 and R2. Right?
Yes, sir.
So we got here OB
sir?
means, yes.
Sir, no, sir, you can continue.
Okay, so 5 OB is 5, so 5 square is equal to OM. So what is OM? O to M. O to M. Actually, OM we don't know. We know the distance from center to center, means O to Q. O to Q we know, but OM we don't know. So, okay. So in place of OM, just left it to be OM. So OM square plus MB. MB we don't know. We are going to find MB. Okay. So we can write MB square. Okay. So just mark it that this is equation number 1.
1 minute.
Hmm.
Sir, why did you remove the radius 1, radius 2? I was writing that.
Okay, I can write it again, no problem. It is R1 is equal to 5 centimeter. It is given, and R2 is equal to 3 centimeter.
Okay, sir.
Okay, these are just symbols for radius. If there are 2 circles, there will be R1, R2. If we have 3 circles, then it will be R1, R2, R3.
Sir,
Okay.
but sir, you're teaching us all of these, sir. But according to the questions, sir, how do we know that whether we have to write these types of formula or not, sir?
Which formula? This Pythagoras theorem.
Yes, sir.
Actually, we need to think like this. If we have a right angle triangle, okay, and we need to
Yes.
find the distances, then in 100% cases, you need to apply Pythagoras. Okay.
So even in the last one there was hypotenuse, sir. Why didn't we use Pythagoras over there?
Where last? Which last?
Sir, over here, what was it?
Okay,
Yeah.
theorem 10.7.
Yes, sir.
Okay, so what was there in 10.7? Okay, we don't apply Pythagoras theorem there. Why don't we apply Pythagoras theorem there? Because
Because
because we take the advantage of congruent triangles. Okay,
There are no congruent triangles over here, sir.
here no congruent triangle are there. Means if you join O to A, then these two triangles will be congruent. Okay, and from that congruent triangle, we will take that AM is equal to MB. Okay, but we already have considered it that AM is equal to MB.
Yes.
Okay, means theorem we will apply in the numericals, all the theorems, and even if we are proving one theorem, so the result of other theorem we can use directly.
Yes.
Okay. So let us proceed. So now here in the this circle there is a triangle. Okay, which one? In triangle QMB. Okay, QMB. So if I draw QMB here, so it is like this. So this is one side, this is length, and this is one side. Okay, it is like this, and here we have point M, here we have point Q, and here we have point B.
Yes.
Right, and this angle is 90 degree. It is like this. So
Yes, sir.
here also we can apply the Pythagoras theorem, and from Pythagoras theorem, by what we can write, Ali?
So we can write OB square. No, 1 minute.
It is Q.
Yes, sir. Okay. QB square
QB square.
is equals to
Yeah.
uh, Q. 1 minute, sir. QM,
Hmm.
QM, and MB.
Yeah. Okay. So QB square is equal to QM square plus MB square. No need to put the comma here. Okay. So what is QB?
Sir,
QB.
QB, it's sir, the radius, sir.
Yeah, the radius of this circle, so it is given as 3 centimeters. So it is placed, we can write 3. So 3 square is equal to QM square plus MB square, right?
Yes, sir.
Okay. So this is suppose equation number 2, right? So now it become a question of like polynomial.
Yes,
Okay,
sir.
polynomial means we have two equations. This is equation 1, this is equation 2, right?
Yes,
And we need to find this value MB. Okay, so
yes,
from here it become a question of polynomial. So let's do it. So if you square this 5, it will become 25. So 25 is equal to OM square plus MB square. And if you square it, it will become 9. So 9 is equal to QM square plus MB square. Okay, and one more thing we have, which is also given, is this 4 centimeter.
yes, sir.
It was also given, na? So what is 4 centimeter? It is O2Q. OQ is equal to 4.
Yes, sir.
Okay, and in place of OQ we can write OM plus MQ is 4.
Sir, I didn't understand.
Actually, this full distance from here to here, it is OQ, na?
Yes, sir.
Here to here. And here we have point M. Okay, so let me draw this line here. Means this is O, this is Q. And there we have a point M. Okay,
Yes,
so for OQ, I can write OM plus MQ.
yes, sir.
I can write, na? Means
Yes,
this
sir.
OQ is this plus this. So we did the same. In place of OQ, I have write OM plus MQ.
Yes, sir.
Okay. So just erase some of the matter. Pythagoras. This is gone. Okay, this is gone. Okay, so now we have means 3 equation. This is one equation, this is another equation, and this is another equation, right? And we need to find the value of MB. Okay, so what we can do from here means in place of this QM or OM, okay, I can put the value from this equation. How? It means that OM is equal to 4 minus MQ.
Sir, I can't understand, sir, this part, sir. Sir,
Actually,
let me explain, sir. Let me explain, okay, sir.
hmm?
Oh, let me explain. Let me try to explain.
Hmm.
So, where is this? Sir, OQ
Hmm.
is equals to 4, sir. 4 centimeter, right?
Yeah. Hmm.
Sir, 1 minute. Sir. Where does this 4 come from?
It is given.
It's given?
Yeah, it's given. Distance between the center.
Okay. Yes, sir.
Hmm.
So, OQ is equals to 4 centimeter, and then OM plus MQ is equals to 4, because we need to find out the whole line, sir.
Yeah. Yeah.
So we did OM plus MQ, which is
Yeah.
4 centimeter. Now we have to write OM is equals to 4 minus
Hmm.
MQ.
Hmm.
Sir, why minus?
Okay, so what we do if it is plus here, plus MQ, and we can take it on this side. Okay, so if we take it on this side, it will become minus. It will go here. Means this is like simple polynomial. Okay, let's suppose we have x plus 5 equal to 10. Ali,
Yes, sir.
x plus 5 equal to 10. Then what is x?
Sir, 10.
No. X plus
No,
5
X
is
is
equal
1,
to
right, sir?
10.
1.
Huh?
X is 1, I guess.
No. This 5 plus 5 will go this side. Okay.
Yes.
So it will become 10 minus 5.
Okay.
Okay. So now we can say X is equal to 5.
5. Yes, sir.
Okay. So this we can apply in, means if we have these variables also. Okay, means here we have the values, and here we have the variables, because OM is a variable. Like this, MQ is a variable, so this MQ will go this side, so it will become OM equal to 4 minus MQ.
Okay, so we change the sides, so it will become
Hmm.
minus.
Yes.
Okay, sir. Understood, sir.
Okay, so in this equation, in place of OM, we are going to write 4 minus MQ. So it will become 25 is equal to 4 minus MQ. Okay, so it was square, so it will become whole square plus MB square.
Sir, how 25?
But in this equation, in place of this OM, we are going to write from here 4 minus MQ.
Oh, okay,
In,
sir.
in place of OM. So in place of OM, we put 4 minus MQ. So it was
Yes.
square, so it will become whole square.
Yes, sir.
Okay, sir.
Is it okay?
Yes, sir.
Now let's erase this. Now this is 25, sorry, 20. This is 25. 25 is equal to. So what is this 4 minus MQ is whole square? Can you expand this?
Yes, sir, we can know.
How? It is like A minus B ka whole square. Do you know what is A minus B ka whole square?
No, sir.
Ali and Zainab?
No, sir.
Okay, so it is, means it is a polynomial, so it will become A square plus B square minus 2AB. Okay.
Yes, sir.
So for this expression, we can expand it like this. Okay. So it will become 16 plus MQ square minus. Ma'am, 5 minutes. Yes. So it is 2 into 4 into MQ. Okay, if we expand this, and
Yes.
plus it is also there, MB square. Okay,
Yes.
so it is 25 is equal to 16 plus MQ square minus, it will become 8 MQ and plus MB square. Okay.
Yes, sir. 16 plus.
So from here onwards, it is 25 is equal to 16 minus 8 MQ. Okay, and it is plus MQ square plus MB square. Means we just change its place. From here to we put it here. After this, no problem.
Yes, sir.
Okay, so from this equation, from here, this MQ square plus MB square, we can take it to be 9,
Yes, sir.
because it is in this equation it is written here MQ square plus MB square, so we can take it 9.
Yes, sir.
So in place of this whole expression, we can put simply 9. So it is 25 is equal to 16 minus 8 MQ plus 9, right?
Yes, sir.
And what is 16 plus 9? So it is 25 is equal to, it is 16, it is 9. So it become 25 minus 8 m cube. Okay.
Yes, sir.
So if we take this 8 m cube this side, okay, so it will become plus 8 m cube. Okay, and if we take this 25 this side, so it will become 25 minus 25.
Yes, sir.
Okay, so 25 will cancel out 25. So 8 m cube will become 0. Right? It will become 0. So if 8 mq is equal to 0, then mq is also equal to 0.
8 m².
Yes, sir.
Okay, sir.
Because 8 cannot be equal to 0, so mq is equal to 0. mq is equal to 0. We got this, mq is equal to 0. Now what is the meaning of this? Is mq is equal to 0 means the distance from m to q is 0, right? And we earlier we have said that OM plus MQ is equal to how much? 4.
Yes, sir.
This is the last equation we put. Okay.
Yes.
So if in place of this MQ we put 0, so OM will be equal to 4.
Yes.
Okay. OM is equal to 4. So now in equation number 1, if you recall equation number 1, it was 25 is equal to mb square plus om square. Okay. So if in this equation in place of this om we put it 4. Okay. If we put it 4, then we can calculate the value of mb.
Yes.
So this is 25, right? So 25 is equal to mb square plus 4 square, right? So mb square is equal to 25 minus this 4 square means 16, so it will go minus 16. Okay.
Sir, 1 minute, sir. After you wrote OM is equals to 4, sir, then you again write 25 is equals to MB square plus OM square. Why?
Yeah, because it is a equation. This we put it as equation number 1. So we can use this equation again and again because we need to find the value of MQ. Sorry, MB.
Okay.
Okay. So this we have find out, and this we need to find still. Right? So we recall this equation. Because here we can put the value 4. So 4 square means 16. Okay.
Yes.
So mb square will become 25 minus 16. And mb square is equal to 9. Okay. So mb is equal to square root 9. What is it? Square root of 9. Zainab?
Sir, I know, sir. 1 minute, sir. 1 minute. 3,
Yes,
right?
sir.
Huh?
3, no?
Yeah, 3. Okay. So if mb is equal to 3, what is ab?
But sir, how is it square root of 9? Like that?
Okay, so if x square is equal to 25, what is x?
Sir, x square is 25. No, 1 minute, sir. 5.
It is square root of 25 means 5. Means if we remove the square, so we put the square root. Okay.
Yes, sir.
Okay.
If we remove the square, we put the
But
square
in
root.
some cases, sir, in the angles, sir, in this circle, sir, now here it is written 5 centimeter like that, sir. But in some cases, there it's written root 5, root 4. It's written like that, sir. Today we did like that. I didn't know how to root it.
No, where it is written root 5, root 4.
No, sir. The question answers I've sent you saying that it is written root 5 like that, sir.
The question you sent to me.
Yes. Yes, sir.
Okay, I will see. Then only I will explain. Okay, so I am asking what will be AB? If MB is equal to 3, so what will be AB?
Sir, AB is equal to 5, right?
No, no. It will become double of this MB.
Okay.
Okay, because MB
Oh,
is
yes,
half
yes, yes. Okay, sir, got it,
MB is
sir.
half of AB, na? So AB
Yeah, yes.
will double of this MB. So you just double this distance, so it will become 6 centimeter. So it is the length of this common chord 6 centimeter.
Yes, sir, got it.
Okay, so in this question means we apply many things like the theorem we prove in this chapter, the Pythagoras, okay, and the polynomials,
Yes.
right?
The tomorrow will be sir, polynomials or what?
Huh?
Tomorrow also circles, right, sir?
Yeah, because in circle we still means need at least two to three class.
Okay, sir.
Okay. Actually, I don't know that how we can do the polynomial in this given time.
Yes, sir. But listen, the paper I sent you, sir. Our class teacher said that 80% of the marks will come with that paper, sir. It's like the
Okay,
questions
so
format will be the
so
same, sir.
what we can do that we will try to solve the paper first.
Yes,
Okay,
sir.
means according to the paper we will do this circle. Okay, so means according to paper, tomorrow we can finish the circle
Yes, sir.
according to the paper.
Yes, sir.
Okay, but still in circle there are
Yes,
many
sir.
things to be learned. But if you want to go just with the paper pattern, so we will do it tomorrow, and then. Okay, ma'am, I am leaving. Yes, ma'am.